Hello there. Welcome to the Learning of Engineering tutorial video lecture. In this video lecture, we are trying to learn the thin spherical shells. So in thin spherical shells, so what type of design we need to be exactly we have to do. So there we can see the diagram is going to be illustrating the spherical shell of the pressure vessel. As we know, these kind of the components are widely using to store the fluid at certain pressure condition, so that we can use for the either transportation purpose or we can use for the storage of the tanks. So there we can see the inside is going to be the vacuum is there, where the material that going to be fluid is going to be we are adding. That is going to be the P is going to be the pressure of the fluid pressure we are going to be taking. Then D is going to be the diameter of your, that means D here, the internal diameter we have to be considered. That then the T is going to be nothing but the thickness of that spherical shell. So then when I am going to be making the two halves, then how we are going to be, because of the internal pressures, then what happened, it is going to be rising more than that. So then the resistance force is going to be shown by the spherical shell is going to be the less, automatically it will make the two halves we are assuming. So there we can see this is going to be the two halves we are going to be making, and the stresses are going to be acting over here in this direction. So can you see this stress always acting normally to that material. Alright, so this is going to be, I am going to be say the sigma 1, right? Can you see the spherical ball is nothing, spherical shell is nothing but the in all dimensions, that means in x and y directions, diameter is going to be the constant. Now we need to find out the stresses are going to be acting inside this material. So then how could we can find out here? As we know, the pressure is going to be acting inside the diameter of the material. That's going to be, that's A, if I am going to be taking here, that is equal to pi by 4 d square, I can take it. Right? So this is going to be the area where the pressure is acting inside the member. So then what I am going to be taking, the pressure is equal to, the pressure of the fluid is equal to the pressure force of the fluid divided by area. So that I am going to be taking, this is going to be the exerted force on that inside the wall, P into, so this is going to be the area that I am going to be writing pi by 4, the d square I can consider it, right? So then this is going to be the pressure force is going to be acting inside the material. So then automatically this, the thickness, that means the shell is going to be subjected to certain resistance forces, that I am going to be taking the circumferential stress sigma 1 is equal to the resistance force by area I can take it. Now can you tell me the resistance area where we have to be considered? That is going to be, it is acting on the circumferential of this material, that is area is equal to, here I am writing pi d is going to be your circumference of your spherical shell, and then the T is going to be the thickness of that member. So then sigma 1 is equal to, so then final simplification Fr is equal to sigma 1 into pi dt I can take it. So now we can see this pressure force is equal to the resistance force. Then in these limiting conditions, we are going to be equating. If I am going to be equating these two, then what I am going to be getting? So here Fp is equal to Fr. This is equal to P pi by 4, the d square is equal to sigma 1 pi dt. Right? So in this case, pi will going to be cancelled out, and the d is going to be 1 times, it going to be, right, d is over. So from this one I can write the sigma 1 is equal to P, that is equal to P into d by 4t I can take it. So this is the way we are going to be calculating the circumferential, the stress acting on the spherical shell. Suppose if I am going to be considering the thin cylindrical vessel, so then what happened? I got the sigma 1 is equal to, that is equal to PD by 2T, we got it. So can you see the circumferential stress in this member is the twice the, that is going to be the twice the stresses acting in the spherical shell. It is very clear that the spherical shells are going to be more safer than your thin cylindrical shell. So but most of the time we can see these thin cylindrical shells are only widely using for the transportation purpose of the fluid. but we are not, very rarely we are using this kind, but these kind of the spherical shells we are using for the stationary application to store the fluid inside, the like oil or the petrol, diesel, we are going to be using for the storage of this one. So this is the way we are going to be developing the mathematical model and to identify the response of the system. So I hope you are able to understand. Still, if you feel any confusion, please put in the comment section so that I can reach you out. Thank you.